Alright, AP, here is sample exercise 3.61, determining empirical and molecular formulas. A white powder is analyzed and found to contain 43.64% phosphorus and 56.36% oxygen by mass. The compound has a molar mass of 283.88 grams per mole. What are the compound's empirical and molecular formulas? Go ahead and press pause now, because here come the solutions. Again, we're assuming a 100-gram sample because it makes turning those percentages into masses much more easily, and the reason we need these to be in masses is so that we can use the molar mass to yield moles. Okay, you can't convert a percentage directly into mole. You have to have grams to convert into moles. So in 100 grams of this compound, there are 43.64 grams of phosphorus and 56.36 grams of oxygen in terms of moles. In the 100 gram sample, we have, after converting grams to moles, we have 1.49 moles of phosphorus and 3.523 moles of oxygen. When we pick out whichever the smallest one is, that's the smallest mole value right there. Divide both mole values by the smallest mole value. Notice how we do that? We get 1 and 2.5. So this yields the empirical formula PO 2.5. Since compounds must contain whole numbers of atoms, the empirical formula should only contain whole numbers. To obtain the simplest set of whole numbers, we multiply both numbers by 2 to give the empirical formula of P2O5. And P2O5 will be our final correct empirical formula. To obtain the molecular formula, we must compare the empirical formula mass to the molar mass. And again, the problem gave us the molar mass of 283.88 grams per mole. So we take that molar mass given to us by the question, divide it by the mass of the empirical formula. Again, you're just calculating the mass of 2 phosphorus atoms and 5 oxygen atoms, adding them together. That gives you 141.94. Division yields whole number 2. And so you're simply going to double both of the subscripts on the P2O5 to yield P4O10 as the molecular formula.